Namaste. My dear students, today we are going to discuss the topic functions, and some presentation I have already made for you, and this is the topic related to class 9 and 10. This will be useful for the students of class 9 and 10 both. So today we will discuss on functions and what is function, what is mean by function, and what are the types of function we will discuss in details today. In the previous classes we have discussed the meaning of order pair and what is mean by Cartesian product, what is relation, that we have already discussed. So I don't want to go in details about relation, order pair and Cartesian product, but today we are going to discuss on the topic function. Well, so here we will discuss what is the meaning of function. Please let's read here. You can see there the definition. Let A and B be two non-empty sets, then a relation from set A to set B is said to be a function if every element of A corresponds with a unique element of B. So for that I would like to show you an example. What does it mean? Here you can see there are two sets, set A and set B. Both of them are non-empty sets. Here A and B, both of them are non-empty sets. So A has got three elements 1, 2 and 3. B has got three elements 1, 4 and 9. By the definition you can understand in this way, every element in the first set, every elements in the first set mean there are three elements, that is 1, 2 and 3. They have image in the second set. That means 1 has got its image 1, 2 is mapped to 9, 3 is mapped to 4. But you can see clearly there every element in the first set has got single image in the second set. Here you just check it well, that every element in the first set means how many elements are there in the first set, all of them have got an image in the second set. That is the first important thing. But the image, when you check the image, you will find only one image, not more than one. So you will have a unique element as an image in the second set. Then this kinds of relation is called function. So here, so try to understand please here what I am telling you here in this example. Just you look at the example only here. Every element in the first set if maps with a unique element or with a single element with one and only one element in the second set, then that is called a function. So first of all you should understand what is mean by function, that you should be clear. Okay, here it is a function. Now let's go on type of function here, one-to-one function. What is mean by one-to-one function? Please here you can see one-to-one function. Let's see there in the headline, one-to-one function means, one-to-one function means here let's see the definition. Let function from A to B be a function from set A to B, then F is said to be one-to-one function if different elements of A have different images in B. That means one element in the first set, an element in the first set will have only one image in the second set. Only one means here we will not have single image for 1 or 2 or 3 elements in the first set. Here every element in the first set will have single image in the second set, not more than one. So here that is called one-to-one function. So this function here, 2 has got its image single element, that is 9, 3 has got its image only one image 4, and 1 has got its image 1. That means there are three different elements in the domain. Each of them have got different images. There is not any common image for 2 or more than 2 elements in this function. So this function is called one-to-one function. Here you can see there in the first set A 1, 2, 3, this is domain. In the second set 1, 4, 9, that is codomain. This is defined as function from A to B. That means A is domain, B is codomain. So here this kinds of function is defined as one-to-one function. Well, Now here, let's go in next chapter. Yeah, onto function. What is mean by onto function? Onto function, please. Onto function. Okay, I think to understand onto function, you should know what is mean by range and what is mean by codomain. First of all, you should understand range. What is mean by range? First, you have to understand. Okay, please, I would like to go in the previous example again. Please, let's see there in the picture here, please. In this function, in this diagram, you check here. Range is a collection of all the images. 1 is an image, 4 is an image, and 9 is an image. Here, this is a collection of images. There are 3 images in this picture. You can see here. There are 3 images, 1, 4, and 9. The collection of all those images is called range. Again, codomain. What is mean by codomain? Try to understand here. What is mean by codomain? Codomain mean here in function from A to B. F is a function from A to B. Let's see there. In this one, the first set is defined as domain, and the second set is defined as codomain. That means codomain means the collection of all the elements that belongs to second set. That means here there are all together 3 elements, 1, 4 and 3. Okay, there may be 9. There may be some more also. How many elements are belongs to the second set? Let's make a collection of all those elements. Yes, here range is collection of images only. Codomain consists of images and some other remaining elements if it doesn't have pre-image also. So here we have got just 3 elements. So we have made a collection of all those, so that is codomain. Well, here you check it, you will find here range is equal to codomain. Range is equal to codomain means they are equal sets. That means to define a function as an onto function, there should be this condition. Means range is equal to codomain, then that is called onto function. So here, let's see the definition, please. What does the definition tells here? Again, I would like to draw your attention here in the definition. The definition says what here? Onto function means let A and B be 2 non-empty sets, and function from A to B, then F is said to be an onto function if range of function F is equal to codomain. Here I have already made it clear. This is the definition of onto function. Well, here let's see the example. In this example, please, I am going to draw your attention here. You can find this is onto function, an example of onto function. Yes, please, you just look at a picture, look at a diagram here. What are the images? You see range means 1, 4, 9. This is a set of range, and in case of codomain 1, 4, 9, so here the elements in the codomain is equal to elements in the range, so range is equal to codomain. That's why this function is called onto function. Now into function. For into function also, just you look at a diagram here. Look at a diagram. What are the images here? 1, 4, 9. They are images. Let's make a collection of images here. When you make a collection of images, you will find in the range 1, 4, 9. And when we talk about codomain means the collection of 1, 4, 9 and 16 also. So please, to define into function, I am going to make a set of range. Set of range means you just see here in the picture, in the diagram, 1 image, 4 is also an image, 9 is also an image. So these are images. The collection of images is called range. I have already said you what is mean by range. Again, when we talk about codomain, for codomain, For codomain, please do define codomain here. Yes, 1, 4, 9 and 16 doesn't have its pre-image. 16 doesn't have its pre-image, but however it is also included because this also belongs to codomain. In this way, when we make a collection of all the elements in the second set or all the elements in the codomain, that is called, we say codomain here means those elements which doesn't have pre-image also included for codomain. For an example, 9 has its pre-image 3, 4 has its pre-image 2, 1 also pre-image its pre-image 1, but 16 doesn't have its pre-image. But when you make a collection of all those elements in the second set, that is called codomain, you just compare them. Here range is subset of codomain. Range is subset of codomain. That's why this type of function is called into function. Please, you can see in the definition also. Well, now we'll discuss about inverse function. My dear students, now we will discuss inverse function. What is mean by inverse function we'll discuss now. You can see there in the diagram here, this is an example of a function. The function is denoted by f. F is a function here. Let A and B be the two non-empty sets. Here 1, 2 and 3 are the elements of set A, 1, 4, 9 are the elements of set B. Yes, then the function from A to B be defined by function f, where you can make an order pair of input and output here, 1, 1, 2 and 4 and 3 and 9. You can see the order pair here. 1, 1 is an order pair, 2 is maps to 4, it is an order pair, and 3 is maps to 9, it is an order pair. Yes, this is function f. Well, so here in this function, f is denoted by a function. So here this is function from A to B. Now what is mean by inverse function? What is mean by inverse function? You can see 1, 2 and 3 belongs to set A. 1, 4, 9 belongs to set B. Set A is domain and set B is codomain. Now please, inverse function, to define inverse function, just you exchange them. Just you exchange them means the input and output will be exchanged. That means 1, 1, then when it is exchanged 4, 2 and when it is exchanged 9, 3. Yes, then this function, the new function, when you exchange input and output, when you exchange input and output, the new function, what you get, that is called inverse function. Inverse function is denoted by f to the power minus 1, that is defined as inverse function. You can see here please, f is a function. F is a function. We define a relation G from B to A so that domain and range of G are interchanged with the domain and the range of F respectively. Means just you exchange the input and output, then the new function derived when you interchange the input and output, the new function you will get, that is called inverse function. So you can define in this way. You can see the example here. So please, here in the first function f, you can see here 1 is mapped to 1, 2 is mapped to 4, 3 is mapped to 9. Then in the second function, just opposite you will find here, 1 is mapped to 1, 4 is mapped to 2, 9 is input, 3 is output here. So the input and output has been exchanged. So the new function derived in such a way is called an inverse function of the given function. So this is the example for you. It will be clear for you. Next one. Okay. Now please, how do you define? I think little bit the letters are not clear for you, but here I am going to make you clear about the inverse function. The function defined from B to A is said to be inverse function of f. It is denoted by f inverse, f to the power minus 1. So f to the power minus 1 is function defined from B to A. Hence, to exist an inverse function of a function, it must be one-to-one function, one-to-one and onto function. The inverse function of any function exists only in case of one-to-one onto function. If the given function is one-to-one onto, then only its inverse function is possible or its inverse function exists. Otherwise, the inverse function doesn't exist. Please try to understand. To exist an inverse function of any function, the given function must be one-to-one onto function, one-to-one as well as onto function, then only the inverse function will be possible. Otherwise, the inverse function doesn't exist. That you have to keep in your mind. Okay, my dear students, please. Now I am going to make you clear through the example here. Just you look at the example here. Let A be a set. It has got its elements P, Q and R, and again B is another set. The elements of set B is X, Y, Z. Let the function from A to B be defined by F is equal to Px, means P is input, X is an output, it is an other pair, Q, Y, it is next other pair, R corresponds to Z. So these are the other pair according to the given function. Here the question is asking you, so that F is one-to-one and onto function, find the inverse function of given function. This is a question. So here solution, let's see there. F, function F is equal to Px, Qy, Rz. This is an other pair of the given function. When we collect an other pair as according to the given function, here P corresponds to X, Q corresponds to Y, and then R corresponds to Z. Different elements of A correspond with different elements of B, so it is one-to-one function. Here we are just going to justify why is it one-to-one function. Of course it is one-to-one function because here you can see every element in the first set, every element in the domain has different images. Means we don't have common image in the codomain. So just you look at the image here, we don't have any common image for any elements that belongs to domain. So if every element in the domain has got only one image or unique image without repeating image, that is called one-to-one function. And again, how can we say it is onto function? Onto function. Yes, for being an onto function, I have already defined you that if range is equal to codomain, it is called onto function. Well, so I have already said you that in case of one-to-one function, if the function is one-to-one function or if the function is onto function, then only you can find its inverse function. This is the special condition you have to keep in your mind. If the given function is one-to-one and onto function, then only its inverse exists. Otherwise, we can't find its inverse function. So here, first of all, you should be clear whether the given function is one-to-one or not, and the next one onto or not. You check first. If it is one-to-one as well as onto function, then its inverse function exists. Okay, my question please, is it one-to-one function or not? Yes, it is one-to-one function. And is it onto function or not? Yes, it is onto function. You can see the given function here. Yes, and then after its inverse function exists. For the inverse function, what I said you, just you exchange input and output, you exchange, then you will get new function. The new function is defined as inverse function of the given function. Here in place of Px you have written Xp, in case of Qy you have written Yq, in case of Rz you have written Zr. Then the new function you have got here, the new function is defined as inverse function of the given function. Well, here yes, I have made you clear in this way also. This is given function. This is given function, and 1 corresponds to 1, 2 corresponds to 4, 3 corresponds to 9. Just you exchange the correspondence, then you will get new relation, new function. This is called inverse function. Okay, let's see in the next example. You can go to next example here. Function f r tends to r, be defined by an equation C here. Y is an output. Then x is an input, fx is equal to 6x minus 3 for x belongs to R. x belongs to R. Find a formula that defines the inverse of the given function. Here we are going to learn how to find the inverse function. Okay, I have already made you clear that the function can be defined by an equation, or a function can be represented by an equation. Function f, that is fx is equal to 6x minus 3. This is defined, this equation defines a function where x is an input, y is an output. So x is domain and y is, you can say, codomain. Well, then x belongs to R. Then you will have to find inverse function. Here f is one-to-one and onto function. One-to-one and onto function, then its inverse exists. I have already said you. So first of all, whether it is one-to-one onto function or not. So you have to check it, and so the quiz here, this is clear that it is one-to-one onto function. So fx is equal to 6x minus 3 given for you, and when x will be input, then let's suppose that y is an output, so you can put here y output here, y is equal to 6x minus 3. That means in this function f, x is an input, it gives you y as an output, so fx is equal to y. Then fx is defined by an equation. Fx is defined by an equation. The equation is 6x minus 3. Then when x will be an output, you will get y as an output. So in place of this one, you write y is defined by 6x minus 3. Then this is an equation, this is a functional relation given to you. To find its inverse function, just you change the role of x and y. Role of x and y means here input is to be changed into output and output is changed into input. So for that, just you change the role of x and y. Role of x and y. Role of x and y mean input and output will be interchanged. Means interchange means for what? What we have to do here? First you suppose let x is an input, y is an output. So in place of fx you write y here. Then let's make x alone. Y plus 3 goes to left here, minus 3 goes to left here, plus 3. In the right hand side 6x, and again let's make x alone here. Y plus 3 upon 6 goes down here. Okay, now you change the role of x and y. Role of x and y means x interchanging x and y. You can write here interchanging x and y also. Otherwise, you have to exchange the role of x and y. Then what you will get a new equation here. In place of x you write y. Then after in place of y you write here x plus 3 upon 6. Then we have changed the role of x and y. Finally you will get new function. This is the new function you have got. This new function is defined as inverse function. For inverse function you can write like this: f inverse x is equal to x plus 3 upon 6. Means in place of y you write f inverse x, because this is the new relation, new function we have got. This is the new function we have got. This is the given function. Then when we interchange role of x and y, role of x and y mean input and output are exchanged. Then we have got new function. The new function is called here inverse function. So this is the process of finding an inverse function of the given function. Well, I can give you here. Let's suppose that fx is equal to 2x minus plus 4. This is a given function. The function can be denoted by f also. The function can be denoted by h also. Yes, h also represent a function here. Here we are sure that x is an input. So first of all, when x is taken as an input, what will be output? So let's suppose that y is an output here. So this is input. Then you get, when you put the value of, when you select the value of x as an input, of course you will get an output from this formula, from this functional relation. So we have already supposed x is an input, y is an output. So output, therefore output you will get from this relation 2x plus 4. Now we are going to find an inverse function. To find its inverse function, first of all you have to change the role of x and y, role of input and output. That means you have to interchange input and output. For what? Please, the process you keep on y, you have to make x alone here, x alone in a side. So plus 4, when transfer to left, then you know that minus 4, 2x is remain here, finally x, 2 into x, there is multiplication sign. The inverse of multiplication sign is divide. So y minus 4, 2 goes down here, 2 goes down here. That means now x became alone. After this step, now this is output, this is input. Y is present here as an input. Here x is input, here y is input. After this step you have to exchange the role of x and y. That means for that you have to write in this way, interchanging the position of x and y. In place of y you write here x here, and in place of x you write y here. This is a new relation. This is called an inverse function of the given function. So here in place of y you can write h inverse x, then x minus 4 upon 2. Well, this is an inverse function of the given function you will find in this way. Okay, dear students, let's see here in the clips once more. Here f x plus 3, x plus 3 itself is an input here. Then that is equal to 2x minus 7. Find the inverse f inverse x, and f inverse minus 4 you will have to find c. Here according to the given question, f x plus 3 is equal to 2x minus 7. This is a functional relation given to you. Here x plus 3 itself is present here as an input, and the output is given by 2x minus 7. So first of all, how do we find f inverse x from the given condition? For what? X plus 3, the input itself is supposed as z, then x plus 3 is supposed as z, and let's find the value of x only. Then it goes like that, 3 is transferred to right, then minus 3, x equal to z minus 3. Well, here now function of x plus 3 is equal to 2x minus 7. In place of x plus 3, as we did before here, it is supposed as z. So fz equal to 2 times, where in place when you put x plus 3 for z, we know that if z is an input, in place of here x, in place of x you can write already found here z minus 3. See here, because x plus 3 is supposed as z, from the same z for x is equal to z minus 3 we have got here. Then x plus 3 is supposed as z. So where is x plus 3? You have written here z, and that is equal to, in place of x we have found here z minus 3. So where is x? There we have written z minus 3 minus 7, and it is continued here. 2 multiplied to z also, 2 multiplied to 3 also. After simplification we have got here f z is equal to 2x minus 13, and z is here input. When z is an input, you will get an output from this condition. Let's write x for z, because z is a variable here. In place of z you can write x here, fx equal to 2x minus 13. Then from the same you can find its inverse function, because the question is asking you to find f inverse x. Where we have got fx, we have got. So from the same process what we did here, okay, after this step we have to proceed the same process to find the inverse function of the given function. Let's go here again. Okay, fx is supposed as y, because x is input, the output is supposed as y is equal to 2x minus 13, and then let's make x alone. Here we have got in this process y is interchanging the position of x and y. Finally we have got the inverse function of the given function. So we have got inverse function, that is y is equal to x plus 13 upon 2, and here that is y. This is an inverse function, that means f inverse x. This is f inverse x. F inverse x equal to x plus 13 by 2 we have got. So f inverse minus 4 the question is asking you to find. So in place of x you can write minus 4. When we write minus 4 for x, the same you will have to write in the right hand side also. After simplification we have got 9 by 2 as f inverse minus 4. So this is the process. Okay, please, I think I will have to write here on the board for you. This is the given 2x minus 7. Yes, here you just look at here, this is input and this is input, and we can get output from here. But we have to suppose first here x plus 3. X plus 3 is supposed as z, because for x plus 3 you can write z here. Just you write what is the value of x plus 3? X plus 3 is equal to z. The sum of x and 3 is supposed as z. Then you can find the value of x also, that is z minus 3. In place of x, when plus 3 goes to right, you can find z minus 3 this way. So where is x? There you can write z minus 3. You should be clear. And according to the question, now yes, when you write z in place of this one, f z is equal to 2x minus 7 we have got. When we write z for x plus 3, we have got this condition. And then f z, z is an input. So here x is to be expressed in the form of z as being z here, but in place of x we can write z minus 3 here. So where is x? You can write z minus 3 minus 7. After simplification we have got here, 2 z minus 13 we have got. When we simplify this one, finally fz equal to 2z minus 13. It means z is an input. If you write 1 for z, here you write 1 for z. If you write 4 for z, the same you have to write here. But question is asking you to find fx. That means let's put x as an input. So here in place of z you write x. In place of z we are writing x here. When we write x for z, everywhere you write x for z. So there is z, so you write x here. Okay, we have got this function. This is a function. You are familiar to this type of function. Now the question is asking you to find f inverse x. F inverse x you will have to find. So to find the f inverse x, the same process what I taught you before, to find the inverse function of the given function, what is the process you have to proceed, that you have to go through. For that, okay, the question is asking you to find f inverse x. Here the question is asking you to find f inverse x. So fx we have got. Now we are going to find f inverse x. For that, let's begin from the same. Fx equal to 2x plus 13 it is given. To find the inverse function, you just suppose that fx is equal to y. We can suppose here that means y is equal to 2x plus 13. Then to find the inverse function, what is the process? You have to make x only in a side. For what? You have to simplify this one. Y plus 13 goes to right, minus 13 equal to 2x, and equal to x is equal to y plus 13 upon multiplication. Inverse of multiplication is division. This is we have got, and after that we have to exchange the role of x and y. Interchanging the position of x and y, we will get here y is equal to x plus 13 upon 2 we have got. So this is after interchanging the role of x and y, the new relation what we have got here, new function what we have got, that is called inverse function of the given function. So it is written as f inverse f inverse x is equal to x plus 13 upon 2. Well, now the question is asking you to find f inverse minus 4. It means you have to write minus 4 for x. When you write minus 4 for x, you can write minus 4 here also, and after simplification you will get f inverse minus 4. Okay, this is I taught you how to find the inverse function of the given function. Please, another example I am going to give you to find the inverse function of this type of function. Here the given function is fx is equal to 2x minus 1 upon x minus 1. It is given function. You will have to find its inverse function f inverse x, and f inverse 3 you will have to find. For what? For what? Please see here. F inverse exists or not. You need to check whether f inverse exists or not. Fx, this x is an input. Then let's suppose that fx equal to y. So in place of fx you are writing y here is equal to 2x minus 1 upon x minus 1. We have written here. After this, please let's multiply, let's simplify them, and we will get this equation. And then here y is alone, you try to make x alone finally, and then after making x alone, then interchanging the position of x and y, you will get this condition. This is, here x is an input, y is output, and then when we change the position of x and y, we will get a new function. The new function is called inverse function. You have to simplify from here, please. I just want to request you how to simplify. You know, when it is simplified, you will get this kinds of condition, and then here is x alone. After simplification, you have to make next equation, making y alone, then y is equal to this condition we have got, and change the position of x and y, we will get this one. After this, the new function is called inverse function, and in place of input x you can write 3 here, and when we choose the value of x is as 3, then you write 3 everywhere. After simplification, f inverse 3 is equal to 2 you have got. Okay, this is the given condition, very simple exercise. Please, this is the first period of inverse function, and then please I just want to request you to do the exercise that you have got in your books, and I suggest to complete the exercise given over there. If you have got any confusion, in the next class again we will continue, and I will make you clear about some of the difficult questions, but it would be better if I solve your problems. When you will solve and when you will feel difficult, in which steps you will feel difficult, if I can solve at the same time for the same problem, it will be very much easier for you and then effective for you. So I suggest you please do the exercise, and today I will conclude my class up to here only. So thank you very much, and we will meet in the next class. Thank you very much.